And welcome back to some topic 6 revision for P1 for your exams. So I'm just going to go through energy transfers, energy transfer diagrams, Sankey diagrams, efficiency, heat radiation, Earth's temperature. Okay, so we covered this only a few lessons ago. So basically you just need to know the different types of energy as listed on the side here, and the law of conservation of energy, that energy cannot be created or destroyed, only transferred from one form to another. Okay, and then you need to be able to do simple energy chains. Here's an example of a torch that changed chemical energy from the batteries into electrical energy, into light and heat energy. So you need to be aware that light is the useful energy and heat is the wasteful energy in this equation. Okay, so like I said previously, conservation of energy, energy cannot be created or destroyed. So the output must be equal to the input. So whatever you put in must be the same as whatever you get out. So whether that be, say for instance, on the torch, input would be the chemical. Okay, that must be equal to the output, so the light as well as the heat. Okay, and then with that information, you could draw yourself a Sankey diagram, which is a visual representation of the energies that are being used. The input, so you remember the thickness of the line. The thickness of the line, maybe I'll show you the mouse here. The thickness of the line here must be equal, which the input must be equal to the thickness of the line of this line plus this line plus this line plus this line. Okay, and the energies that are wasted usually go out down the bottom. The one that's useful comes out to this side here. Okay, I hope that's okay. And then we're looking at efficiencies. Okay, so often we have to calculate the efficiency of a device. Here we're looking at two different devices: the usual light bulb that you use in the house and an energy efficient light bulb. So here, like a normal filament light bulb, you only have 9 joules of useful energy compared to 91 joules of wasted energy. So we can use an equation, which is this equation here: efficiency is equal to the useful divided by total times 100. Now remember what I said before, the smaller number here should usually go on top. Okay, so back to this again. So energy efficient light bulb, you've got now 100 joules go in, but this time 45 is useful, 55 is wasteful. So if we did the equation, the filament light bulb would be 9% efficient, and the energy saving light bulb would be 45% efficient. So in the exam you could be asked to look at two different examples of two appliances, could be light bulbs, could be anything, and basically use the equation here to be able to calculate the efficiency of the device. Okay, so that was the first lesson pretty much covered. Second lesson, we looked at heat radiation. So I got you to draw the graphs of two different cans losing heat. The darker can absorbs heat much faster, but also emits the heat at a greater rate. So that's why the line went down at a steeper angle compared to the silver, which is better reflecting heat. Okay, and then finally, how does this relate to the Earth? Well, some of the groups took outside, we looked at the sun, and in theory the Earth should give out as much heat as it takes in. But over long periods of time, what we're seeing is that the Earth is gradually heating up. So that balance cannot be right. So what's actually happening, therefore, is we're taking in more heat than we're giving out. Okay, and this is leading to global warming and other issues alongside that. Okay, okay, and that's basically topic 6, very fast. Okay, so any questions, let me know.